Hello everyone, welcome back to the third part of Pagination. I highly recommend watching the first and the second part to follow with us, the link in the description below. In this part, you will learn how to define a source of data as a single source of truth while paginating using a special class called Remote Mediator that I will explain in a bit. First of all, we need to set up our database. Why, you might ask? Because we want to cache our data to a local database to allow the user to use the data even in offline mode. Basically, this will give our application a better user experience. So inside local, inside entity, I'm going to create the entities that we will need for handling our cache. So first of all, the first entity will be just created a shortcut for it. Room database entity, let's call it TV show entity. So TV show entity will be the first entity. So it's gonna be the same as the DTOs, but with a few minor changes. So the first field will be the ID. The second field will be the name of the TV show of type string and a rating double genre or genres. It's gonna be a list of string. And here we have to create a converter to convert a list of string to string and vice versa. So here again, images, list of string as well. And one last element will be update or updated of type long. So I'm going to create a mapper for this function to map from the entity to model. So function to TV show, so it's gonna return TV show model. So this is the first entity. I'm going to create the second one. So of course here I have to add the table name. I'm going to create the table name in the constant file first of all. So here in the constant file, I'm going to create all the table names that I'm gonna need. So the TV shows table and persons table, TV shows detail table, and the TvMania database. So it's pretty much the name of our database, and TV show remote keys that we're going to need afterwards, and bookmark table. So this is basically the constant that I'm going to need. Here it will be table name, TV shows table. So the second entity will be the TV show detail. So of course it will have a primary key. Let's change the name of this primary key to :info with the name equal here TV show. So TV show detail ID. It's gonna be of course here auto increment or auto generated with the value of true, and let's give it the value of null. So the second field will be TV show ID. So let's call it, let's do :info name equal TV show ID. So basically that's gonna be our foreign key, and a URL of type string, premiered of type string as well, official site of type string, and it is nullable, and a summary of type string. I'm just creating this in accordance with the DTO that we have here inside. It's the same thing here, pretty much the same fields as TV show DTL DTO. So that's pretty much it. And we need to specify here the indices. So as I said before, this will be our foreign key. So I'm going to specify first table name. So it's gonna be TV show detail table, and the indices will be just one index. Let's copy the value, TV show ID, and it will be a unique value. So here I'm going to do unique equal true. Now let's add the foreign keys. We have only one foreign key, so it will be foreign key. So for the entity, it will be TV show entity, and for the parent columns, it is ID. For the child columns, it will be the TV show ID, and when deleting any TV show, the corresponding TV show details will be automatically deleted or updated. So here it will be foreign keys dot cascade and on update foreign keys that's cascade. So we are done declaring our TV show. We do have to add another entity which is for actors or person. I'm going just to call it person entity. And for the ID, I'm going to change this ID to another one. So it will be a colon info with name equal person ID. It's going to be, of course, of type long. The second field will be val name of type string. So as I said before, it's going to be the same thing as we have done here in the person DTO. So inside the, so again, the other one, it will be URL. So val URL, perhaps to see the official website, if I'm not mistaken, of this person. Val images. So those are the medium and original images. So it will be a list of string. And of course, we're going to create a converter for that matter. And val updated of type long, if the data of the person has been updated. So I'm going to add a mapper function to person. It's going to give us person model. And here at the end, we will add here updated with updated. So that's pretty much it for the person DTO. And let's come back, of course, for the person entity. I'm going to come back to the DTOs, and I will basically see if we have anything else to uncomment here, because as I said before, I have commented. Okay, I'm going to uncomment this mapper. So basically this it's going to map for us from the entity. So it's going to map for us from the DTO to the entity, because we are going to need it. And that's pretty much it, I think. So this is for the TV show detail. Let's go to the image. Don't have to do anything here. Rating with the same thing, and TV show detail. Of course, here I'm going to uncomment this one, because we need to, map from TV show DTO to TV show entity. So that's pretty much it. And what else? We need, of course, to declare our relationship. Basically, the relationship between the person and TV show is many-to-many relationship. So we have to create a new entity, which is, and let's call it TV show person cross reference. So first of all, I'm going to rename the ID to basically this entity will save or will contain the TV show ID and the person ID. So here it will be TV show, and another value will be person ID of type long. So I'm going just to change the column names. Here it will be column info. So I think that's pretty much it for now. We have to, again, specify here the primary keys are basically the two fields here, which are TV show ID and person ID. And one last thing, I have to provide here the indices, only one indexed, which is the person ID. So if you are confused at this point, I highly suggest to watch the course that I have created for or about Rome database. I have explained everything in detail and everything you need to know about Rome database. So these are pretty much for the cross-reference. Now we have to create the relationship between the person and the TV show, which is going to contain the TV show with the details. So it's, instead of calling it TV show with detail and persons, it's a long name, so I'm going just to call it TV show. So it's going to be a data class, and I'm going to call it TV show with details. So let's go, and first of all, we need to annotate the parent entity, which is TV show entity with embedded. So it's going to be TV show of type TV show entity. Now we need to have the details. So we need to link between TV show entity and TV show detail entity. So here it will be val, I'm going to call it detail. So it's going to be of type TV show detail entity, and it's gonna be a nullable. And here I have to specify the relationship. So the relationship here will be for the parent column. So for the parent column for the TV show entity, which is ID. So I'm going to put here ID, and entity column. So in entity column, it's gonna be called TV show ID. Here, of course, entity column with TV show ID, and we are done with the relationship between TV show and TV show detail. Now we need to specify again the relationship between the TV show entity and the list of actors. So I'm going to create here a field called actors. So actors will be a list of person entity. And here we have to define the relationship again, because it's many-to-many relationship. First of all, we have to specify the entity. So the entity will be person entity. Next, the parent column will be the ID. So the parent column, which is the parent column of TV show entity, it's called ID. And for the entity column, it will be called person ID. We have to specify the junction with the parameter associated by. So junction, and basically the junction is the TV show cross-reference. And we have to again specify the parent column, which is TV show inside the junction here. It will be TV show ID. And the entity column, it will be inside the TV show person cross-reference, will be person ID. And we are done defining the relationship. I'm going just to create here a function. It will be a mapper function. Let's call it to TV show detail. It's going to give us TV show detail. So that's pretty much it. We are done declaring here our entities. So now we have to go to define our database. So I'm going to create a new Kotlin class. Okay. So the database, it's going to be a Kotlin class TvMania database. So it's going to be an abstract class. It's annotated with database. And inside the database annotation, we will do the version of the database. It's going to be 1. And the entities, 1, 2, 3, 4. So those are the entities that we have. And I'm going to add another parameter here to disable exporting schema. False, because we don't need it actually. And we are basically done. So we have declared here our, we have added our entities. Now we have just to add our DAOs. So I'm going to create for each entity, its specific or its proper DAO. So it's going to be here. Let's call it, let's create the first one, which is person DAO. So for the person DAO, let's insert persons. So it's going to have in parameter persons as list of entities. And for the delete, going to call it here delete all. Delete from table name, which is person table. Let's import person, and we are done with the first DAO. The second DAO, it will be for TV show. We're going to group everything inside one DAO. So here, I'm gonna call it TV show DAO. So insert TV shows. It's gonna be TV shows, list of TV show entity. The second method will be to insert the TV show detail. So we have to insert, of course, the cross-reference with the same thing. So it's gonna be here a list again of TV shows cross-reference. So those are the most obvious ones. So the second one, let's clear here the table TV show. Copy this function. Clear TV show detail here. TV shows table. TV show detail table. So TV show detail table. So those are basically the most obvious ones that we will need. Now let's add a type converter to our database. So let's go back to the database package, and here I'm going to create a class called I'm gonna call it controlled converter, because it's gonna be, of course, a controlled converter. Why controlled converter? Because we are going to use a third-party library in order to achieve the conversion. So here I will do a Kotlin class. I'm going to call it controlled converter. It's going to be a normal class. So as a dependency, we will need the JSON objects. So private val JSON of type JSON. So basically to convert JSON to lists of string and vice versa. So here we have to annotate this function with type converter. It's going to be a function, and let's name it from JSON to string list. So this will take in parameter a JSON formatted string, and of course it has to return a list of a list of string. And the other function, so type converter function, now the opposite will be string list to JSON, or let's call it just JSON string. Of course JSON is a string, so it will be here. It's gonna of course return a string, and in parameter it will have strings list of string. Great. So for the first one, it will return try. So why we are surrounding it with catch? Because it will arise an exception, and the type of this exception is JSON syntax exception. So in this case, it will return an empty string. Otherwise, so JSON dot from JSON. So the first parameter will be the JSON as source, and the objects for the conversion will be, so the type token here in our case will be a string. So a list of string, and here we have to add parentheses and curly braces dot type. So with the same thing here, it will return try catch exception. So JSON syntax exception. It will return an empty JSON string, and for the conversion here it will be JSON dot to JSON. So the first one from JSON. Now we are talking about to JSON. The source will be string or strings, and the object, let's specify here the type. It will be type token, and it's going to be a list. And what else? String here. Let's open here the parentheses. I'm going just to remove space from here. Dot type. So we are done creating our converter. Let's add the converter or the controlled converter here. So this will be type converters. So type converters and controlled converter class. And I'm going to add the abstract function person DTO or DAO, and the last one, which is function TV show. So those are the DAOs that we have done. So the last, of course, the last step will be how to provide the database in dependency injection. So under this function, I'm going to add another function showing how to provide the database. So it's going to be a singleton provides function provides TvMaze database. So it will take in parameter an application of type application, and it will return TvMaze, not application, but TvMaze database. So here it will return room dot database builder, and here for the context it will be the application. For the class it will be TvMaze database class Java. For the database name it will be TvMaze database, and here I will add the type converter that we have created. Add a type converter. It will be controlled converter with JSON as a parameter or as a dependency, and I'm gonna call fallback to destructive migration. And finally I will do here build TvMaze database. Of course here we have forgot to inherit from room database. So let's come back to the, so that's good. So we are done setting up our Room database. Now we're going to talk about how to paginate with Remote Mediator. Now we have prepared our database. We are ready to show paging library how to load data and save them in our local database as a cache using a special class called Remote Mediator. I'm going to create a new class inside the package paging in the data layer. I'm going to call it tvShow Remote Mediator. So this class should inherit from mediator or remote mediator, and it has a key of type integer or string, and the data will be tvShow, or the value will be tvShow entity. So what is basically remote mediator? Remote mediator class is an abstract class that will coordinate loading from the API and saving data to our local database. When we reach the end of caching, or the app reached the end of cached data, remote mediator will send a signal to ask for more data from the remote data source and cache it afterwards. So this mechanism will provide the UI with the paging data at the end. So our class will depend on the API because we want to get data from the API and private val, and another dependency will be the database of type TvMania database, and we have to implement one method, which is, of course, this paging or this remote mediator is still experimental, and we have to implement one member, which is load method. So load method, which is how to indicate to paging library how to load the data and to save the data. But we have to override another method that we need to allow us to trigger the load method during the initialization, which is initialize. Override suspending function initialize. In our case, we want to refresh the data during initialization. We will call here initialize action dot launch initial refresh. When calling the initialize action dot initial refresh, this automatically will trigger the load data and to refresh the stream of data. So the load method will be triggered when we need more data due to one of the three following cases. The first case, if we call launch initialize refresh in initialize function as we did here. So this is the first case. So of course this will trigger the load method as we said before, or the user call refresh directly or explicitly from the UI. And the third case will be when the load results with the latest page that has the previous key or the next key set to null in case of prepend state or append state. As we have done in the paging source, we have to calculate here the current page. So first of all, this method should return to a load result or mediator result. This can be a mediator that's success or error. That's why we are going to surround the block with try catch. So here exception with an exception. So in case of any error, we will return mediator result that error and exception as a parameter. And here we have to, of course, return the last statement will be mediator result that success. But we have a lot of things to do before doing that. So first of all, we have to calculate the current page. So the current page will be calculated in accordance with three states: load type that refresh. So the load type that refresh when the content is refreshed in case of updates or initial load. The load state that refresh when we want to request more data, either by using initialize action that launch initial refresh in the initialize method, or by calling refresh directly or explicitly from the UI. The third case will be load type that prepend, which is basically when we have reached the end of pagination with previous key or the previous page is null. And the last one, which is load type that append, this will be the end of pagination with the next key or the next page is null, depending on the load state or the load type. So as we have said before, in case of refresh, in case of prepend, and in case of append. In case of load refresh, we have to calculate the next page closest to the current position, and we're going to take from it one step. So here I'm going to call a function that will calculate this next page closest to the current position. Get next page to current position with state equal state. So this function, of course, it will be a suspending function, and it has to give us an integer, nullable integer. Before moving forward, when we are dealing with a remote mediator, we have to create, first of all, we have to create an entity that's going to store, or where we are going to store the previous page and the calculated previous page and the calculated next page. So I'm going to create an entity real quick here. It's gonna be called TvShow or TvShow's remote keys entity, or just TvShow remote keys entity. We're going to store next page. It will be integer and nullable, and previous page, it will be integer, of course, and nullable. I'm going to add just :info, and the table name, I'm going to change here the table name to TvShow remote keys table name. And we need, of course, in the DAO, 3 methods. So the first one, we will insert the list of keys. So it's going to be called insert TvShow or TvShow remote keys. I forget I have to add here the entity. So I'm going to add another method that's going to clear the remote keys. TvShow remote keys, clear TvShow remote keys table. And another method that's going to allow us to retrieve an entity by an ID. So it's going to be a query, select everything from the table TvShow remote keys, where the ID equal the IDs we will provide in the parameters. It's going to be a suspending function, get TvShow remote key with ID. I think the ID here, no, I think the ID that we have provided here is long. That's pretty much it. So I'm going to create here a value. It's going to be called position. It will be state dot anchor position. So state dot anchor position will allow us to retrieve the latest accessed index. So if the position is not null, what we will do, we will call state dot closest. So here it's going to give us the closest item to position with the provided position, which is it. And this line will give us the entity. So this is the current entity. So if we highlighted this, it's going to give us the TvShow entity, which is nullable. So if the now we can calculate, or we can get to the next page. So I'm going to do here next page equal entity. So if it's not null, it will be, or directly we will do here. We need, of course, to declare here a new parameter, local field. It's going to be called TvShow DAO. It's going to allow us to obtain the remote key from the local database. So next page equal TvShow DAO dot get TvShow remote keys, and the ID will be, of course, let's create here another value. So you can, of course, do this in one single line, but I want just to explain things line by line so you can understand. So it will be entity dot ID, and of course the ID is nullable, is null. Here we will do ID, or directly here. So here I'm going to do entity dot ID dot let. We will do here TvShow DAO dot get TvShow remote keys with the ID is it. So here we have the entity TvShow remote keys entity, and we will do here next page. Of course, I forgot here to add TV show remote keys entity, and here it will be next page. So I'm going to assign this to a variable or a value. I'm going to call it val next page equal entity, and we will return finally the next page, which is basically a nullable. We can do it directly just like this. We can't do this, of course, by in one line, but it's okay. I want you just to understand what is the algorithm. So first of all, we're going to calculate the latest accessed index. This latest access index will allow us to retrieve the current or the closest entity to the current or the closest position after getting that entity, so it can be null, of course. So if the entity is not null, we can retrieve the next page from the table that we have created, TV shows remote keys entity, because every time we are paginating, we are going to calculate the next page and the previous page, and we are going to store them in our database. So we can retrieve them afterwards when calculating the next page closest to the current position. So if it's not null, we will get the that entity, and we're gonna call next page, and we will return the function. So inside the refresh key here, as we said before, it will, if it's not null, we will do here -1. So if the whole statement is null, I'm going to do here an else operator. So the current page in this case will be null. It will be, sorry, 1. So this is how to calculate the current page in case of load.refresh. The next one will be in case of load type that's prepend. So what we will do in case of load type that's prepend, first of all, we have to calculate or to get the remote keys of the previous page. So we have to calculate the previous page number according to the first key from the saved previous page of the remote keys. So we have to get the previous page, or the remote keys previous page, from the database. So I'm going to create another function here that's going to calculate that for me. So it's going to be a suspending function. So the function will be called, just to be self-explanatory, get previous. So as I said before, I have to get the previous page for the first item. So I have to get the previous page for the first item, and the state will be the same here. It's going to be state of paging state, integer, and TV show entity. And it's going to give us an integer, nullable integer. So first of all, we have to get the load results. So the load results will be obtained by calling state and using the pages property. And we have to get the first element if it or null. So we have to get the first element according to a condition that we have to set here. So first or null. With the condition, the data should not be empty. It is not empty. Otherwise, it's gonna give us a null load result. So now we have obtained the load result. What's next? We have to obtain the entity. So here I'm going to call a new variable or a new value, call it entity. It will be load result. Again, if it's not null, with the data, and we will get it because it's a list. We'll get the first or null. With the same thing, the entity is going to be of type TV show entity with the TV show with null, because if you don't have any result, it's going to give us null value. So now that we have the entity, we can get the previous page. So I'm going to call here previous page. Here I will do entity let. So we have here, of course, the entity. I'm going just to call it TV show entity, and I'm going to do TV show DAO that get TV show remote key, and the ID will be TV show entity dot ID. So this is the previous page, and it is nullable. Sorry, this is not, of course, the previous. And finally, we have to call here the previous page. So the previous page is nullable. So we can just do this directly, a return here. And let's reformat the code, and we have obtained the previous page. So I'm going to recap. First of all, we have to get the first element by a condition. The condition is, which is the data is not empty. We're going to store it because it's going to give us anyway load result. So we have to get the entity for the first element. If the entity is not null, we will obtain the previous page. Otherwise, the function will give us null. So a value, it's going to be called remote keys previous page. It will be the function that we have created. Get previous page for the first item and state equal state. And now we have two cases. If remote keys is null, we have to return a mediator result dot success with the end of pagination set to the condition if the remote keys or the remote keys previous page is not null. Otherwise, we will assign the previous page to the remote keys previous page. So the previous page, the value of the previous page will be whether the remote keys previous page, and because it has to be not null. If it's null, we will return the whole function will return mediator result dot success. And we have to specify the end of pagination. So the end of pagination is tested if the remote keys previous page is not null. If it's not null, we have reached the end of pagination. And the last statement will be the previous page that we have calculated. So in the same manner, I'm going to create the function that's going to allow us to calculate the next page for the last item. So here it will be get next page for the last item. With the same thing, instead of doing first or null, it's going to be last or null. And instead of previous page, we will do next page. With the same thing here, I'm going to create a value. I'm going to call it remote keys next page. It will be get next page for the last item with state equal state, and the next page will be of course the value of remote keys next page. If it's not null, if it's null, we will return mediator result with end of pagination reached. Sorry, here it has to be success. When end of pagination reached, when of course the remote keys next page is not null. And the last statement will be next page. So afterwards, we have to create a value. It's gonna be going to get basically now the TV shows from the API. So it will be TV shows or API dot get TV shows, and page will be the current page that we have calculated. So and we have to test if we have reached the end of pagination. So end of pagination reached will be TV shows is empty. So now we have to calculate the previous page and the next page to store in the table that we have created, TV show remote key entity or remote keys entity. So val for the first or the previous page, it will be, so with the same thing as we have done in the TV show remote paging source, if the current page that we have calculated equal 1, there is no previous page. Otherwise, it will be current page minus 1. With the same thing, the next page, if the end of pagination reached, we're no longer talking about next page. Otherwise, it will be the current page plus 1. So now we have calculated the previous page and next page. Now we have just to store the data as well as the previous key and the next page. So I'm going to surround this whole thing with a database.transaction. If any problem occurs, it will ignore all the other operations. So with transactions or with transaction, of course, this can raise an exception. So just in case of an exception, we're going to print here exception. I'm gonna print here the stack trace, so it's gonna be exception dot stack trace for each stack trace element. So I'm going to do here log dot debug, and with the tag exception. So here it's gonna be just to show the file name where the exception occurs. Stack trace element dot file name and the class name. This is not mandatory, so you can just do here just the class name and the file name. So it's stack trace dot file name, or here class name. So that's pretty much it. It's not mandatory. So just we want to show the error to the console, not to the application. So inside the try block, I'm going to test if we are on the load type dot refresh. So we are refreshing the data. What we will do basically here. So if load type equal load type dot refresh, we will delete all the tables. So I'm going to create here a new function, suspending function. It will be called delete cache. So delete cache will delete basically TV show with clear, let's clear TV shows table and its related tables, and we're going to clear TV shows remote keys table. So TV show remote keys table. So when refreshing the data, we will clear all the data tables. So it's gonna be delete cache. And next we're going to store the keys. So the keys will be TV show, the list of TV shows. I'm going to map every single element to, so here a parameter will be called TV show remote keys entity. And for the next page, sure, for the ID, it will be TV show dot ID. And for the next page, it will be the next page that we have calculated. And the previous page, it will be the previous page that we have calculated. So now we have successfully, not previous page, it's going to be previous page. It will be the previous page. So now we have stored the TV show remote keys entity to be saved into the keys value. So afterwards, I'm going to add the keys first. So TV show DAO.insert TV show remote keys and keys equal keys. I'm going to save again the, I'm going to insert, so TV show DAO, gonna insert the list of TV shows. So insert TV shows, and TV shows will be TV shows that we have obtained from the API, and I'm gonna map every element to TV show entity, and we have saved now the list of TV shows. So now we are, if everything is saved correctly, finally here we have to the last statement should be mediator result dot success, and indicating if we have reached the end of pagination. So end of pagination reach should be end of pagination reach that we have calculated here in end of pagination reach. So this is too much work, but it's worth it. So I'm going just to recap everything from the beginning. So when you are dealing with a TV show remote mediator, first of all, you have to create an entity that you have to store in that entity the previous key and the next key calculated from the API or your source of data. So the remote mediator, basically, it will coordinate the loading from the API and saving the data in the same time. So if you have if you override the method initialize with initialize action.launch initial refresh, when doing that, this will trigger the load method. So the method load will give us will request the data from the API and save them to the local database. So the implementation of a load method, the load method will be triggered in 3 cases. The first one, if you have if you override the method initialize with a return value of initialize action that launch initial refresh. The second case, if the user called the refresh from the UI. The third case will be doing append on prepend state if the previous key and the next key are null. We have to calculate the current page. So the current page will be calculated in accordance with 3 states. For the load.refresh, what do we mean what load.refresh? When we want to request more data, either from receiving the value launch initial refresh from the function initialize, or if the user call a refresh from the UI. So in this case, what we have to do, we have to calculate the next page closer to the current position. This will be calculated with the help of the last index or last access index anchor position. Using that, we will get the entity with doing states that's closest item position with the position that we have calculated with anchor position. Finally, we can get the next page by taking the value from the database with get TvShow remote keys that we have defined in the DAO. And this value should be, of course, minus. We have to do not -1 because we are now on the next page, but we want the current page. So we have to do -1 if the whole statement is null. So which means that we are on the first page. So we're going to assign 1 to the current page. So next, in prepend. Prepend occurs when the previous key, so we are reaching the end of pagination with the previous key is null. So in this case, we have to calculate, first of all, let's get the remote keys previous page from the database. So in order to do that, we will first of all get the first element if it's not null. If it's not null, we will get the first element or the first entity. So the first entity, it's going to allow us to retrieve the previous page. If the whole statement is null, it will return null as a return type. So if the statement returned null, we will return a value with mediator results that's success. And we have to indicate the end of pagination. If the end of pagination will be tested or obtained by testing if the remote keys previous page is not null, so we have reached the end of pagination. Otherwise, we will set the value of previous page to the value of remote keys previous page that we have obtained from the database. With the same thing, we will obtain the next page. So now we have calculated the current page. We can perform the API call. We get the TV shows, list of TV shows, and we have to test if we have reached the end of pagination, which means that the list of TV shows is empty. So we have reached the end of pagination. Now we have to calculate the previous page and the next page to save them in our database, more specifically inside the TV shows remote keys entity. So if we are on the page 1, we don't talk about previous page in this case, so the previous page is null. Otherwise, it will be current page -1. Great. Now for the next page, if the next page, if we have reached the end of pagination, there is no next page. The next page will be null. Otherwise, the next page will be the current page that we have calculated before plus 1. So the whole thing can, if in case of any exception, we will run this as a transaction. So this whole thing will be ignored if there is any error whatsoever. So if we are inside if we have triggered the refresh state or if we are in the refresh state, we will delete all the cache. So delete all the cache, it will clear TV shows table as well as the remote keys. Next, we have to store temporarily the keys. So the keys will be as follow. the ID will be the TV show ID, and the next page is the next page that we have calculated, and the previous page will be the previous page that we have calculated. We will insert the remote keys first. We will insert the TV show. So now we are caching basically the data, and we can, if you want, you can add here an error, or to throw the error to the user. You can do whatever you like with this exception. So basically here, I'm just going to show to the log the exception. Finally, the last statement should be the mediator result.success. And we have to indicate if we have reached the end of pagination. If any error occurs, we will return the mediator result.error. So this is basically how to do a TV show remote mediator. Now we have to use it in our context. So let's go to the implementation of TV show repository. As you might notice here, we are not going to change the view model. If you have set your projects correctly, if you have set your clean architecture with the correct way, you won't need actually to touch the view model. And as you can see right now, we're going just to add some minor changes to the TV show repository implementation, so we can benefit from the new cached data, or the new feature that we have added to our application. So I'm going to comment this function because we don't need it actually. We're going to implement it again. First of all, I'm going to call a variable or a value. I'm going to call it remote mediator. It's going to be the remote mediator that we have created. So it will be TV show or TV show remote mediator. It will need as a parameter an API and a database. So the database here, let's add another dependency. So here database. So now we have declared the remote mediator. Next, we will return a page or a pager with some configurations. So the pager, so the configurations first, it will be page in configuration. For the page size, it will be, as we did before, the page or page size. Now we have to add another parameter, which is prefetch distance. So what is prefetch distance? So the prefetch distance parameter consists of how far as limits of loaded data we can trigger next call of load method. For example, if the prefetch distance set to, for example, 13, which is basically a number more or equal than 1, we going to load 13 items in advance. Those items already been accessed. If the value is set to 0, which means that nothing will be loaded until explicitly requested, which is not recommended, by the way. Why not recommended? Because we want to observe in our UI, for example, the placeholders and the end of list while scrolling. So we're going to set here the prefetch distance, for example, to 2. So which means that we're going to load 2 items in advance. I'm going to specify here the remote mediator that we have created and the paging factory or the paging source factory. Of course, here I'm going to add another method in our DAO that's going to give us the list of TV shows from the database. So I'm going to come back to the get TV shows, and here inside the so after get TV show remote key, I'm going to add a new query that's going to allow us to select everything TV show, of course, TV shows table. So what is new here, let's call it first get TV shows. So instead of returning a flow, it will return a paging source, and with the key here it's going to be integer because we have used paging source as an integer key, and a TV show entity. So this is basically the paging source factory. I'm going to add here a private val TV show DAO equal database dot TV show DAO, and here I will do TV show DAO dot get TV shows. So afterwards we will use the property flow, and we will map the element to TV show model. So inside the map method, I'm going to do it.map every element. So the element here, which is an entity. So it's going to be TV show entity to TV show model. And of course we have to, because it's still experimental, I'm going to add here experimental, going to move it to the top here. And that's pretty much it. So this is basically how to do it. If you have noticed, I'm going to come back to the view model. Where is the view model? Home view model. If you have noticed, there is nothing. We have not touched anything because we have changed pretty much the core of the application, and we have set everything correctly. So with the view model won't care from which the data comes from, whether a local database or remote data source. It will always use the Pagination data as a single source of truth. So what I want to do here, I'm just going to add a carousel state to get the images. I want to show some images in the home screen. So it's going to be a mutable state flow. I'm going to call it carousel images. It will be of type list of image model, and it's going to be empty list as a default value. So here I will do carousel images dot value equal a function that I'm going to create afterwards. So to do add carousel use case to list of use cases. So in order to do that, I'm going to create a new use case. It will have a dependency, as we have done before, private val repository, and we will override the operator invoke. So the function, of course, it will have no parameters, and it will give us a flow of list of images. It's going to import image, going to import flow, and it will return the repository. And let's come back again to the repository interface, and here I'm going to add, so it's going to be a function get TV carousel images. It's going to be a flow of lists of image, get the list, okay, get 4 elements for images to inject in carousel. So it will return a list. So let's come back to the use case, get carousel image, and that's pretty much it. So it's going to give us, of course, get 4 images to inject in carousel. And in the list of the DAO, or in the list of the TV show use cases, I'm going to add val get carousel images equal get carousel images with the repository equal repository as a dependency. So let's leave it empty for now. I'm going to come back to TV shows. So I'm going to create here a query that's going to give us a random TV shows with a certain limits. So you can limit it for 3 or 4 random TV shows. So this is the purpose. So it's going to be select everything from TV show table. So order by random. This is the SQL query, and limit, and the limit will be limit as a variable or a value, so as a parameter. So it's going to be, of course, let's create it as a stream of data. So function get random TV shows, okay, get random TV shows, and limit is an integer. This function is going to give us a flow of list of TV show entity. Going to import here flow. So now we have just to implement this function inside the repository implementation. So this will return TV show DAO dot get random TV shows, and I'm going to create here a function, not a function but a constant. I'm gonna call it const preferred carousel images count, or I'm going to just create a preferred carousel slide count. So it will be 4 here so here R. So inside it will be limit equal preferred carousel slide count, and we will map every single element, or the list, of course. So here it will be map again. Here it is a TV show entity. So TV show entity, we're going to convert it to an image. So TV show entity, okay, here it's going to be an image, and for the medium it will be TV show entity dot images dot first, as we have done before, and for the original it will be TV show dot entity dot images dot last, because we have as a convention we have done, we're going to store the medium in the first element and the original image at the last element, which is, we do have 2 elements anyway. So this is basically the implementation. Now we have just to come back to the home view model. So here I'm going to do TV show use cases dot get carousel images, and because we have a flow of data, we're going to get only the first snapshot, and we are good to go. So the rest is gonna be very easy. All we have done now for the carousel doesn't have nothing to do with the paging. We're just going to add some decoration for our application. So here I'm going to listen or to observe the carousel state. Yes, here of course we have to add the dependency database, and here again database, TvMaze database. So inside the, as I said, inside the view mod or the home screen, all I'm going to do here is I will add carousel. So carousel images by view model dot carousel images state dot collect as state. That's pretty much it. So for the carousel, it's fairly straightforward. I'm going to add here an item for the carousel. So it's gonna be under the our logo, and it's a carousel view. So first of all, let's add a modifier. It will be modifier dot, you can skip this part if you want, height equal 26 to 260 dp, and for the, it's gonna fill the max width. For the padding, I'm gonna give the top, okay, it has to be top, okay, I'm gonna give it 8, and for the bottom I'm gonna give it 20 dp. For the start I'm gonna give it 16 dp, and end I'm gonna give it 16 as well. So for the URLs of the carousel, so by the way, carousel view is a custom composable that I have created. So carousel images dot map, it's going to show the original images, and for the shape of the carousel it will be material theme dot shape dot large, And let's give it a crossfade of 1 second. I think we are good to go. So before I end the application, let's see if we didn't forget anything. So for the dependency injection, I think everything is set correctly. For the database, we have done almost we have added all the needed entities. For the type converter, oh yeah, here we have to add provides type converter. Let's see the declaration of entities. So this is a primary key, and TV show entity has one primary key, that's fine. And for the TV show entity, that's good. For cross-reference, of course, we shouldn't here add the primary key because we have done here primary keys. And let's see the DAO. Here I have to add the, not entity, but it should be person entity. I think that's pretty much it. Let's run the application, and it's loading the application, and we are on the splash screen. So it's loading the carousel, or it's loading the data. And we have an empty carousel because we don't have any data for now, because we are getting the carousel basically from the data. We're going to do just one experiment because we are now caching the data. So I'm going to switch off the Wi-Fi, and I'm going to launch again the application, and let's see the loaded data. Of course, we cannot see the images because it's not been loaded yet. It's not been cached yet by Coil. So for the next part, if you want to see the images, so now of course we have again some data to see while on offline mode. So we're not online. The Wi-Fi is switched off, and we can see of course the data that we have cached. So this gives a better user experience. So it has loaded, this is not bad. It has loaded enough data. So those are cached data, as you can see. So if we click on Kirby bucket, we want to be able to see, of course, the okay, I don't like the error message. To solve this problem, I'm going to do here vertical arrangements. So arrangements. So that's center. So we can align the items in the center vertically. I think that's pretty much it. For the horizontal alignment, I'm going to do here simply box with modifier equal modifier fill max width with content alignment center. Going to run the application, and let's see. So I'm going to switch off my Wi-Fi. I'm going to see Kirby bucket. So the TV show you are looking for does not exist, so it's centered in the center of the screen. And let's come back, and we can still paginate through the data, or we can still paginate even in the offline mode. So I think that's pretty much it for this third part of our tutorial. So this is how to work with Remote Mediator. As you can see here, we haven't even touched the home view model, because we still are using the same syntax or the same code as we have done in the previous parts of a remote data source. So basically this will inherit, or this will enhance the user experience while using the offline mode. Still can see some data in the application, but for further pages, the user won't be able to see those data. So at least the user have some data to work with. For the last part of this tutorial, it will be a bonus. So we will continue the path of a single source of truth. And that's pretty much it for this third part. I hope I was helpful. It's been a pleasure sharing with you my knowledge. Take care of yourselves and bye-bye.